this section is about area, understanding area. And it's a simple section. It only has 3 theorems. The area of a rectangle is length times width. The area is LW. If you have a square, which is just a special rectangle, and the sides are all of length S, well, just like the rectangle is one side by the other side, the area of a square is side times side. S times S, of course, is S squared. The area of a triangle. Pick one of the sides to call the base. Call this the base. If you go to the opposite angle from the base and you go down at a right angle, that's called the altitude, which I'll use H, the letter H. The area of the triangle is 1/2 the base times the height. And there's one more thing we need to know. If you have some area, you have 2 areas. You have this area, and you want to add on that area. They're separated. Area 1 and area 2 is separated by one line. They have a common side in common. That area is equal to the area of region 1 plus the area of region number 2. So now we're going to go and try to figure out some area problems. Now, I do want to go over one thing. For example, for a rectangle. If this rectangle is 3 inches by 5 inches, the area is one side times the other side. We all know that 3 times 5 is 15. But just like 7 times 7 is not 7, and x times x is not x, inch times inch is not inch. It's square inches. Now, what does it mean that that area of this rectangle is 15 square inches? Well, since this is 3 across, I can divide it into 3 equal parts, each 1 inch. Okay, this is 1 inch, this is 1 inch, and this is 1 inch. And likewise, since this is 5 inches, I can cut them up into 5 single inches. That is, this is 1 inch, and this is 1 inch, and that's another inch for the third one. You have a 4th inch and a 5th inch. In fact, so now we have a number of squares inside, and they're each 1 inch by 1 inch by 1 inch by 1 inch. We call that red one 1 square inch. But we have 15 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of these little square inches. Now, what if you have a circle and I tell you the area is 10 square inches? Well, how on earth do you get 10 square inches in a circle? Well, nobody said you have to get 10 complete square inches. I mean, here is 1 square inch, and a second one, and a third one. So I guess it's more than 10. 4, you have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Suppose it is 20 square inches. Now, all I'm saying is, so now we have bits and pieces of our square. Well, I guess you can get a square here. Okay. Well, here you have a portion of a square. And over here, you have another portion. And over here, a portion of a square. And a little portion here. And here you have a portion of a square. And here, actually, you have a whole square. And here, you have a portion. And another portion. And here you have a portion. And a portion of a square. Well, if you're into arts and crafts, you can take these portions or squares. So let's make believe that we had complete 1, 2, 3, not make believe, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, we have 19. Let's suppose that those portions of squares, if we cut them and we put them together, we actually come up with 3 more squares. They may have come from very bizarre pieces. Let's blow up this one. That square could have come from this piece and that piece, one piece, a second piece, a third piece, a fourth piece, a fifth one, a sixth piece, or seventh piece, an eighth, and a ninth. Okay, it came from a lot of pieces, but nonetheless, we were able to make a perfect square using those pieces. Actually, 3 perfect squares with nothing left over. With nothing left over. For the record, what would it mean you have 22 and a half or 22 and a third squares? Well, I think it's clear what 22 square means. What would it mean if you have a third of a square? Well, divide it into 3 equal pieces. This up here is a third of a square. Same thing for this one. That's a third of a square. This is another third of a square. So you can have a fraction of a square. Half a square, you can just cut it down the diagonal, and that's half. Or you can cut it down the middle, that's half. But nonetheless, it's literally half of a 1 by 1 or 1 inch by 1 inch square. Or 1/3 of it. So that's what it means when we have a non-rectangular figure, but yet we talk about square inches. So suppose you have a figure that looks like this. This is 3, and this is 2, and this is 4. And this is 5, and this is 11. Now, the idea so the question is, what is the area equal? The idea is to somehow partition this so we get rectangles. Remember, square is just a special rectangle. We get rectangles or triangles. We're mostly going to deal with rectangles. I can go like this, straight line, and I can go like this. So now we have 3 regions, 1, 2, and 3. So the area A is area 1, the area of region 1, plus the area of region 2, plus the area of region 3. But the area of region 1 is very straightforward. And the reason it's straightforward is because it is a rectangle, and it's 3 units by 11 units. It's 33 square units. Plus region 2. We'll do that last. Plus region 3. Well, this is 11, just like that was 11. This is 11 by 4. Assume that everything that looks like a right angle is a right angle. This is 11 by 4. 11 units by 4 inches. 4 units. 11 units by 4 units. That's 44 square units. Okay, now region number 2. I'm telling you that this length is 2. I just need to know that length. But just remember, the sum of the parts is the whole. This length here is 11 units. And it's the same as this length here. Well, I know that this portion is 5. So the top portion must be 6. 5 plus 6 gives you 11. Now, this rectangle here is 2 units by 6 units, side by side. 2 times 6 is 12 unit squares. 33 plus 12 plus 44 is 30, 40, 87, 89. It's 89 units squared. If each of those numbers I wrote down were feet, it'd be 89 square feet. Now, I'm not saying that this is the only way to have done this problem. You could have partitioned it like that, and then region 1 would be all of that, and maybe region 2 would be that, and region 3 would be like this. Well, again, we know this is 3 and 4. Well, if this is 5, well then so is this. And we know that this whole thing is 11, and since this is 5, like it says here, then that's 6. Now, the top, well, this portion is 3, just like the bottom. This portion was given to be 2. So up here, this is 2. And this is 4, just like this. So this whole top is the sum of those 3 numbers, which is 9. So the area of region 1 is 9 by 6. 54 units squared. The area of region 2 is 3 by 5. One side is 3, the other side is 5. When you're looking at the sides, don't pick this one and that one. Or don't pick this one and this one. Pick ones next to one another. Pick this side, side 1, and a side next to it. One of those two. The area of 2, like I said, is 3 by 5, 15 square units. And region 3 is 4 by 5, which is 20 units squared. Now, unless I made a silly error, the total area should be the same. 50, 60, 80, and 9. 89 units squared, just like we got before. So I'm not saying it's unique how you do it. In some ways are easier than others, but you need to get rectangles, which include squares, or triangles. You need to get one of those. For example, if you have something that looks like this. So all turns are assumed to be right angles. This is 8, up and down is 3, and then 4 across, and 5 up and down. And say 2 and 3. So what we want to do is find this area. So we need to partition it. It's not unique how we partition it. Maybe I'll go across here and across here. So I have one region, a second region, and a third region. And if the three areas, or if two areas can be joined with one line, I can add the total area will be the sum of the two partitioned area. That is the total area, T for total, is area 1 plus area 2 plus area 3. The sum of the parts equal the whole. Now what is area 1? It's 3 by 8. It's 24. Let's assume all units are in feet. How do you assume it? It needs to say it. Imagine all these units are in feet. 3 feet. Okay. Area 2. Okay. So this whole distance is 5, just like that whole distance is 5. But this piece is 2, like it says over here. So it turns out that that piece is the remaining 3 feet. Okay, wonderful. Now what we need to do is find out how long it is from left to right. How long this is, or how long that is. They're the same. Well, from this portion is 8. And the balance, well, that's 4. So the whole thing is 12. There's 3 by 12. 3 times 12, 36 square feet. Now the bottom. Well, we know this side is 2. How long is this? Well, we've just learned that all the way across, remember, it was 8, well, maybe 8 should have gone here. It's 8 plus 4. The whole length is 12. But we're just taking away 3 feet. This is 9. 12 minus 3 is 9. 12 minus 3 is 9. It is 9 by 2, which is 18 square feet. And you add these up and you should get 78. 24 plus 36 is 60. And 18 more is 78. 78 square feet. Partition it. Your classmate, or maybe you yourself, might have partitioned it differently. Doesn't matter. You still get 78 square units. Now, I'm going to give you the perimeter of a rectangle. It is 100 feet. Because perimeter is not square units, it's a length. Okay. Now, suppose you have a rectangle, and I tell you that this here is 30. And I want you to find the area. Well, what I like to do is think half of the perimeter. Half the perimeter is 50. That is this plus that. That's halfway around. That should be 50. Well, I know the bottom is 30, so that must be 20. 20 feet and 30 feet. And you know, this is 20 feet and this is 30 feet. The opposite ones are equal, 30 and 30. If you walk all the way around, it is 100 feet. But the area is 30 feet by 20 feet. 30 times 20. Well, 3 times 2 is 6. Just don't forget the 2 zeros. Feet. Sorry, 600. Feet times feet is feet square. That is what the area is. 600 feet square. So in other words, you go into the fence store and you say, I want to buy 100 feet of fencing. And if you, because you want to build a dog pen, and if you build it 20 by 30, you get 600, square feet for your money. Foot times foot is foot squared. You'll get 600 square feet for your money. If you made it really long but not so high, say this is 5 feet, and remember this is half the perimeter. This must be 45 feet because that used up 50 feet, and the other half of the perimeter will be 50 feet. So what's the area going to be? And the answer is it's going to be 5 feet by 45 feet. 5 times 45 is 225. Foot times foot is foot squared. 225 square feet. If you make it very narrow and you use 1 foot, well then that's going to be 49 feet, because that used up half the perimeter, 50 feet. And the area, well, will be 1 foot times 49. 1 times 49 is 49 square feet. And one more. If you use 25 feet on all sides, 25 times 25 is 625 square feet. Okay. Now, when you go to pay for the 100 feet of fencing, do you really think that the owner of the fencing store cares that you're going to get 49 square feet or almost 12, 13 times that area, 625 feet, or 600 square feet, or 225 square feet? The answer is no. The seller is going to say, look, you are buying 100 feet of fencing and it costs $5 per foot. The feet cancel out. Dollars are the units that survive. 100 times 5 is $500. Please give me $500 or leave. You have to pay $500 for the 100 feet of fencing. Okay, so the bottom line is you pay the same amount, whether you get 49 square feet or 225 square feet or a whopping 605 square feet. So when you build this dog pen, basically you want to, maybe you find 100 feet of fencing in your garage and you say, oh, I'll use this to build the dog pen. Well, whether you paid $0 for it or $500 for it, assuming you have all the land that you can possibly ever need to build this dog pen, why not build the biggest one, the one that has the largest area? Just want you to be aware that if the perimeter is the same, the area can be different. Well, what is the area of a square whose sides are all 12 inches? They're all 12 inches. Well, 12 times 12 is 144 inch squared, square inches. What if I tell you the area of this rectangle is 100 centimeters square, 100 square centimeters. And I tell you that the length is 20 centimeters. Well, what is the width? Well, one side times the other side. We'll assume the units are the same. On one hand, 20 times W times centimeter times centimeter. It's 20W centimeters square. On the other hand, you were told it's 100 centimeters squared. The first thing I would do, believe it or not, is I would divide both sides by centimeter square. So now I have 20W is 100. Let me work up, please. 20W is equal to 100. Then I would say to myself, 20 times what is 100? The answer is 5. 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. 20 times 5 is 100. So W is 5 centimeters. Again, the area is still 100 square centimeters. Four times y. Well, 4 times 25 is 100. It's 4 centimeters. That was given. So the other side must be 25 centimeters. One more. What is the area of the shaded region? What is the area of this shaded region? Maybe you have a portrait, which is 20 inches by 10 inches. And of course, you build the frame. You build the frame. 25 inches by 15 inches. What's this area? Now, the thing that really concerns me is if you give a student a subtraction problem, they'll have no problem doing it. Like, what's 72 minus 63? 9. Okay, very good. Johnny did well. The thing is, though, you're not always going to be given the problem. You're going to have to be able to figure it out. Now, basically, if you compute, this is a big area with the frame and all. If you compute the big area, and then you take away the area of the picture, then you get just what we wanted. Okay? And that's what I mean by you need to understand when to do subtraction. The whole area, well, it's 25 by 15. 25 times 15 is 375, in this case, square inches. And we want to take away this area, which is 20 by 10, 20 inches by 10 inches, which is 200 square inches. And well, that leaves 175 square inches. When you take this away, what's left over used up 175 square inches. Let me do one more problem. Suppose you have a square. Call it A, B, C, and D. And then you pick the midpoints of this square. Okay, so suppose the area of A, B, C, D is 64. 64 square feet. Square feet can be written as feet squared. Okay, so we're going to write it down as square feet. And then you take the midpoints of each of these. Call it W, X, Y, and Z. And you do like this. Well, I want the area outside of that diamond. I want to know what this area is. I don't know if I said it, but ABCD is a square. And turns out that if you square 8 feet, you get 64 square feet. That is each side of the square. The outer square is 8 feet. Since Z is the midpoint, and so is W, X, Y, and Z, we know that each of these pieces are 4 feet. 4 feet. 4 feet. 4 feet. And 4 feet. In fact, let's find the shaded area and the area inside that diamond shape. 4 feet. 4 feet. Okay. Now, each one of these triangles, triangle number 1, triangle number 2, triangle number 3, triangle number 4. If it's not clear what triangle I'm talking about, triangle 1 has W, B, and X as its vertices. This triangle 4, for example, it has X, C, and Y. That triangle. And the 2 on the bottom. Okay. Each of these triangles are 4 feet by 4 feet. Remember, okay, that's enough for me. They're 4 feet by 4 feet. I'm going to call this the base. Now, I guess I'm drawing triangle number 2. This is a right angle. Now, I've always maintained that if you have, this is the base, you go to the opposite angle and you come down, straight down until you hit at a right angle. And that's the height. In other words, if you have a triangle that goes like this, that's 3. What's the area? The base is 3. What's the area of this triangle? Well, I need the height. You need to figure out that length. It meets the base, even if you have to extend the base. It meets the base at a right angle. So the area of this triangle would be 1/2 times 3 times whatever h is. But in our case, we know h. It's 4, because the side that was given actually is the altitude. And the base is 4. The area is 1/2 the base times the height, which is 8. 2 goes into 4 2 times. 1 times 2 times 4 is 8 square feet. Because this was really 4 feet and that was 4 feet. Feet times feet is 8 square feet. Each of these little rectangles is 8 square feet. Each of those triangles, excuse me, are 8. Okay, so the 4 triangles, I should say, or have said, the area of the 4 triangles, well, there's the 4. The area of each triangle is 8 square feet. So it is 32 square feet. That's the shaded region. The area marked S, well, it's the whole area, 64 square feet. It's the whole area. It's the whole area minus the triangular areas, minus this. What's left is the area inside, the area that I have marked very nicely as area S. So it's the whole area minus the area of the 4 triangles, and it turns out 64 square feet minus 32 square feet is 32 square feet. Turns out the area of those 4 triangles actually equals the area inside. Now, I didn't actually anticipate that happening, so let's see if we can show why that is. Triangle 1, I just drew the mirror image, and we'll call it triangle 1 prime. Triangle number 2, I draw the mirror image, and there it is, the mirror image across this line. Call it 2 prime. Triangle 3, if I draw the mirror image along this line, call it 3 prime, it will be area 3 prime. And triangle number 4, if I draw the mirror image, it will give me this. And of course, those would have the same area. So yeah, you have a lot of symmetry going on there. So absolutely, it makes sense that the area of the 4 triangles is equal to the area of that inside, the one that I called S. And this completes the section on area. It's one of the easier sections, I hope.